right, so in this segment, we're going to be talking about the toolhead setup, and we're going to go individually on each die. So we're going to start with station 1, which is inserting the case into the shell plate. We'll talk about our first die station, which is station number 2. And there we're going to be using a decap die. And the first thing we want to do with any dies is we want to take them apart. We want to make sure that everything is clean, free of debris, make sure they're lubricated, and ensure that any pieces that are screwed together are tight. So in this case, I'm going to grab with some soft jaw pliers, and I'm going to take this decap pin and just make sure that it is tight. Okay, now we'll reinsert back into our die body so we can insert it on our tool head. So for this, we're going to use a new piece of brass. What we're going to do first is we're going to put this piece of brass into station number 2. We're going to set the die in the tool head with just a couple of threads. And on our setup menu of our tablet, we're going to press move to bottom. Now, the goal is to look closely at the decap pin so it can come through the bottom of the case, but we want to ensure that we only go as much as needed. So once it enters through the bottom of the case and sticks through the top plate, we lock it in place. By doing so ensures that we don't go too far to damage the flash hole. Once we've got that, we lock it in place securely. All right, so moving on, next we're going to talk about the universal hold down in station number 3. So again, I'm going to take my die and I'm going to just verify that everything is clean, free of obstruction, and that any insert or screwed on pieces are tight before my installation. Okay, now we'll reassemble and install in the tool head. So again, I'm going to be using a new piece of brass. It's more important here because we're going to be setting the swage as soon as we set this hold down. And so you can also purchase a cutaway so you can visually see, but a new piece of brass is going to work just fine. So with our brass here, we're going to do a move to bottom, and we are going to lower the die down until we make contact. So we're going to feel for that contact. Right there, we bottomed out inside the case. There's a few things that are important to this. One is we want to make sure that our die body is not touching the shell plate. We also want to make sure that we're not applying downward pressure with the hold down, as its job is to limit the upward travel, not apply downward pressure. So once I've got the feeling, I've contacted, I stop and I lock it in place. Okay, now with our die tight, we can raise our swage rod up. And for this, you want to visually look at it. So we're going to raise the rod until it makes contact inside the primer pocket. Now the wrenches needed for this would be a 5/16 and a 1/2 inch. And so as we get inside, we want to go until it bottoms out. Now we don't, again, want to apply a lot of pressure because this is a new case, and so we know that that is to spec right there. I feel just slight resistance. I'm going to stop and I'm going to lock my nut in place. Now, if you're dealing with military crimped cases, we can always adjust this slightly up or down as needed once we get into the loading operation. Now we have a properly set hold down and a properly set swage. And now we have properly set the hold down and our swage rod. All right, so next we're going to set our sizing die over the priming station, and so we'll talk about both of these in depth. We'll start with the sizing die itself, and what we want to do is remove the decapping insert from the die. Now you can leave it hollow or you can put the cap on. I prefer to put the cap back on. In this case, we're not going to place a case underneath it. We're going to do a move to bottom, and we're going to install the die. What we're looking for is to get as low as we can without contacting the shell plate. And so we're going to use the spring to see how close we can get. And so if we notice, we get all the way down to our spring assembly and we can see that it touches. This allows us to be sure that we've got about a 10 to 20 thousandths gap before contacting our shell plate. So when we see the spring move up and down, we want to back off to avoid contact and lock it in place. Now to check our work, I'm going to put the press in neutral by pressing stop and neutral. We're going to use our 11/16 box end wrench to verify that we are not touching the shelf plate with our sizing die. And this goes for any die. Perfect. Now we'll end cycle, and we can test this with our case after we've set up our priming station. So step one is we want to put primers in our bowl. We've designed this to support the primers, in most cases, that hold 100, by simply holding it over and sliding the box apart. I recommend starting with 300 small pistol or small rifle. Our goal is to maintain between 100 and 300 anytime we're loading. So we're now going to power on our vibratory controller. All right, I've moved so you can get a better view here. And so I've got a couple different controls in this case. I've got my frequency or speed controller on my vibratory, and I've also got an agitation control underneath the motor itself, which is adjusted with a 3/16 Allen just right underneath. Now by adjusting this, I can increase or decrease the agitation by going all the way to the highest point, which will shut it off, and then backing off slightly. I can then go back to increase the speed or frequency and ensure the primers are making full travel so they can make it down through the ramp. Some things that are important to note is you want to make sure that nothing is touching the bowl, including this primer sensor call cable or the cover, and you also want to create a good distance gap between the ramp and the outlet on the bowl itself. These adjustments can all be made by loosening these four, which we'll show you just momentarily. Now, as you see, once it's full, the primer call sensor tells the system to shut off. As we're loading and consuming primers, this will tell it to turn back on. And so we want to make sure this is free of obstructions as well as not touching. So now going into the adjustments necessary, we have one bolt in the middle of the bowl, which is an 1/8 inch Allen, and that allows us to rotate the bowl in either direction. We also have 4 nuts on the bottom of the platform, which I'll loosen for you. And these are elongated, so it allows us to move the entire bowl in any direction that we need to. Our goal is to create a very small gap so as to not make contact, allowing it to vibrate, but also not be too far away, which would allow the primer to just fall out. So once we have that set, and we test it through running the machine, we've adjusted everything we need to ensure that this is properly functioning during operation. So we'll close the lid. We can now cycle the press a couple times. Okay, what we want to do is hook up a hose to the underside, which is accessed on this 3/8 nipple. And for now, we're just going to tuck this under. Now this is going to catch any unused primer so that we can reuse it and put it back in the bowl as necessary. So verifying operation, primer call sensor is functioning properly, our vibratory bowl is feeding correctly. Now we're ready to use our case in station number 4 so we can take our first priming depth while we're sizing. So we're going to hit run in cycle, or you could choose to hit single cycle. And now we want to measure our primer depth and ensure that it's what you're looking for. Manufacturers would follow SAMI specifications, as any consumer should. Some people like to have them deeper than others. So once we're set primer depth, we can move on. We've verified that our sizing die is coming fully down, and our priming system in the same station is fully operational and functioning. Now we'll move on to our next die. All right, next we're going to go over station number 5, which is our expander, or you can refer to it as a flare die. Again, it's always important to make sure that the die you're using, everything is tight. In this case, we're using a pistol, so it's just the insert top to bottom. An example of a rifle, you would have a threaded insert, and you always want to ensure that that is removed, inspected, cleaned, and in some cases you might even want to use a light Loctite so that it never comes loose on you. And so we're going ahead and place that in the station. For this, we're going to use our primed case. We're going to set it underneath station number 5, and we're also going to have our projectile handy that we're going to be loading with so we can ensure we get a proper expansion. So the step 1, we're going to move to bottom. And now we're going to hand thread the die down until we feel pressure. So I've made contact with the case. Now I can usually push through this by hand. And this is going to be a trial and error. So we'll go slowly and we'll end cycle. Now I can remove this case, take my projectile and test. So as you can see, I do this a lot and I can get it right the first time. The proper expansion is not to go so far as to create a flute or a trumpet, looks like a musical instrument. It's just enough to support it so where you can thoroughly support it all the way around. So initial adjustment on die setup, this is good. You may have to go slightly more once we're fully loading. And so what I'll do is I will give it a tiny bump and we'll lock it in place. Now I will reinsert this and we'll do a single cycle and double check. Very nice. I don't see a large gap around it. Doesn't look like a flute, and it's firmly supporting the projectile. So that is a properly set up expansion die. So in this segment, I'm going to talk about the digital powder measure, its operations and adjustments. First off, how to set it. So with a 5/64 Allen, we're going to loosen this set screw, and this allows the lower portion to rotate on the die. And you'll notice that you have an upper and a lower. One of the key things I want to point out is on the back, the reason we have these is because we have a micro switch, and that is open and closed on this lower. So you'll even hear it click, you'll see it actuate. What we want to make sure is that when no case is present, that it doesn't separate and drop powder, but when a case is present, that it does separate and activates and drops the correct powder charge. So for starters, we're going to do a move to bottom, and we're going to lower the body down until we see the upper and lower start to separate. Okay, so now you can see that we've gone too far. So now we want to back that up until they're closed and then go an extra turn just to be sure. At this point, we can lock it in place. So we'll hit end cycle. We will lock our jam nut, and with the correct angle, we will lock our set screw. So now to check function before we go any further, we're going to once again do move to bottom, ensure the upper and lower do not separate, hit end cycle. Now we're going to put a case underneath it and do the same process, move to bottom. Now we're ensuring that the micro switch is open and visible so we would get correct activation. Okay. Next we want to raise the plunger to the top position, and now we can fill it with powder. So it's important to make sure that our powder is tamped properly. This is going to ensure that we have consistency in our powder charges. So I will spend some time just making sure that this powder is tamped all the way down. Now each powder is going to be slightly different. A ball powder is going to settle faster, and so forth. So by doing so, it's just going to really increase the consistency right off the bat. Okay, we'll place our cap. And now with our plunger in the fully upright position, we can power our box on. Okay, now the adjustments to be made are by loosening the locking feature on the plunger, and by turning in, I will reduce the powder charge. By unscrewing, I will increase the powder charge. My target in this particular load is 3.7 to 3.8 grains. So I will start here, and we'll take a case. We're going to place it underneath. We're going to verify on our tablet that the powder measure is enabled, and we're going to press run and end cycle. We could also use the single cycle feature. Now, rule of thumb for me is I always take the first charge, pour it back in, and repeat the process. So now we begin to weigh, and I like to do a rule of 3. So we're going to repeat this process until we've ensured that we've got the proper adjustment. What I don't do is make an adjustment based on one charge. I take 3 charges, which give me an average, and I perform an adjustment based on that. So I'm right at 3.7 and 3.8. And we'll repeat one more. .7. So that is good. Now my initial adjustment put me exactly where I want to be, but it's always wise during the first 10 rounds, 20 rounds, 50 rounds to double check our powder charges, which is the most important part of what we're doing, and make adjustments as needed so we can ensure that we don't over or undercharge any of our case. So the last feature I want to point out on it is the difference between 2-stage and 3-stage. And so simply put, 3-stage gives it a extra location to stage halfway down during the downstroke for high-speed pistol reloading. 2-stage is always either filling with powder or dumping with powder, which is for your rifle, whether it be 223, 308. You will notice it's labeled large rifle. You may find it helpful for small rifle as well. So I'd like to give an example. In 2-stage, it will never stage in the middle during the process. Now, as I go to 3-stage, you'll notice as soon as the tool head moves, that it positions itself in the middle, so it only has half the travel to do. This assists us in high-speed pistol for low-grain charges. Now, you could use it appropriately if you have a pistol, however you're loading something like 45 long Colt that takes a lot of grains. It's all about consistency. So whether you're doing 2-stage for your smaller large rifle or 3-stage for your small pistol, you'll find the benefits in the pre-staging itself for the higher speed small pistol to just be faster operation. At our next station, we have the optional powder sense, which we highly recommend, and I'm going to show you what you're going to find. So inside of the box is the sensor assembly and the die body, which is held with a 5/64 Allen screw to separate these. You'll also find that we have 2 upper stems, which is a micro and macro. To explain what that is, if we look closely, you'll see that there is larger surface area on the macro than the micro. The way this optical sensor works is it shines a beam through the lower or upper slots in each. This is going to give us a tighter accuracy. This is going to loosen it up. We recommend this for bottleneck rifle. We recommend this for your pistol cartridges. You'll also see that we have 4 probes. These are for caliber specifics. This being a 45, this being your 9 or 38s. This would be your short version for like a 223 or a 30 cal or 308. So for this, we're going to use the micro and the 9mm probe. And so what we want to do is put the upper stem in our housing. We will then be able to thread in our lower rod and ensure that it's tight. This is a pro tip that I do, and this is specific to a very fine powder. An example of like a Lovex or a Shooter's World powder is that I will create a small checkering using a file by simply running across the same grain, turning it 90 degrees, and then running again. What this allows is a very small checkering surface on there, which will do a much better job of sitting on top of a very fine powder. So now we can insert it into our die. We can turn our Allen down, but not all the way. we're going to head and set this in the tool head and get it ready. Now the first thing we want to do is we want to get our properly charged case. And so what I've done is I've already set this to 3.8 grains. So now with powder in our case, we're going to place it underneath that station and we're going to move to bottom via the setup menu. Okay, now what we want to do is with my left hand I'm supporting the cable assembly and with my right hand I'm lowering the die. What we're waiting for is the center rod to come up and become flush with the ears of the sensor. And here we are starting to rise. Okay, just when we get close, we'll temporarily put this in place. At this point, I'm going to take my connector and I'm going to plug it into port number 4 on my console. Now we're going to repeat this procedure. So end cycle. We're going to take this case, we're going to empty it out, get a fresh drop of powder, and perform a move to bottom. Now we can check our work. So we are lined up, which tells me I'm going to lock it in place. And if you need to make further adjustments, you would be doing so now. And again, I'm going to use my 5/64 to turn this so when I'm operating the press in front of it, I have a good view. Feel free to raise the sensor up and down as needed, depending on your powder charge. So now we're going to check operation. So I've taken a fresh case, I've placed it underneath my powder measure. We'll do a single cycle, and on my sensor menu, I will now enable the powder sense. Now I've already plugged it into port 4. This doesn't require a calibration, so when I hit run, it should allow this to go by, and on the very next stroke, it should stop at the top. As you'll see on the screen, it says case powder level incorrect. And that's because it went down, made a stroke, there was no case or powder present at all, not set correctly, and therefore it stopped the machine, and I can hit OK. We've just verified operation of our powder check, and we can move on to the next station. So the next station is going to be our bullet feeder or bullet dropper die. And what we're going to start out with is removing the upper section and just swing it out and put it in the bullet feeder for now. We're going to need the projectiles that we plan on using, and we're just placing the die in the tool head. So just a few threads, and we're going to drop these projectiles from the top until they're poking out. Okay, next we're going to take our flared case. Very important that it's flared to the right depth that you chose. In this particular case, I have everything ready to go, and I'm going to do a move to bottom. What we want to do is lower this die down, and we're going to take it slow. As we make contact with the case, the center portion begins to lift up. Now we're going to go extra slow. What I'm looking for is as soon as my bullets drop, I'm going to stop and give it one additional half turn. So we're almost there, dropped. Now quarter, half, and lock it in place. Now this works with almost all calibers. The longer the projectile, the longer you can give the additional turn. Vice versa, the shorter, an example of a 380, you might go slightly less than a half turn. And so with that temporarily put in place, we're going to end cycle. You can see that it placed the bullet correctly on my case, but we're always going to repeat the procedure, check our work. So first, let's lock the die in place. And take our same flared case and reset it underneath. And as I said, I'm a rule of 3, so perform a single cycle. Again worked, and one more. Excellent. So that has properly set the die body. Now we can return the dropper assembly back. We will put it in place. We'll hold it firmly with the 5/16 Allen, 5/64 Allen. And now we're ready to trim off our additional springs. And so make sure nothing is in the shell plate. We'll remove the upper section, and we're going to do a move to bottom. So temporarily remove this. We're going to let the spring dangle. And now you can see the height that has the excess spring that we don't need. So with a good pair of side cutters, mark that location and remove the additional spring. Now it's okay if you cut a little too much off, you can simply stretch it. If you don't cut enough, you can simply make another cut. And so in this case, I'm going to give it just a little bit more. One helpful pro tip is to cut at an angle, like this, which will allow it to go back into the die much easier. And if you look from the bottom, you will see exactly how much you can thread it, and you don't want to go too far. Let's go ahead and put that back in place. We'll hold it there with our 5/64 set screw, and we can verify that it's not pulling up on it. Cycle, we can verify that it's not drooping down. So just hit run. Now this is correctly set. You're ready to do the final adjustments on the top, which there's several information you can find on Double Alpha's website or in the manual, but very simply, by using the correct amount of cards based on the projectile and loosening this Phillips screw, you're able to adjust the shelf in or out, and I can go more into depth in another video. All right, this next die setup is going to be our seating, and we've got our flared, primed, and bullet-ready cartridge. We're going to place that underneath the seating station, and we're going to do a move to bottom. So what's important when we're setting these dies, these last two, is we want to make sure the die body is looked at differently from the micrometer upper portion. So if you notice, I back the micrometer all the way up. What's important to me is that I don't put my die body too low to make contact with the shell plate. So while I'm doing this, I can view over and look to be sure that I stop before the body of the die comes to the shell plate. So in this case, I'm going to stop right here, and I'm going to face the micrometer towards me as the operator. So I can then lock this in place. All right, now with that locked into place, we can do the rest with the micrometer. And so what we want to do is just go down, feel contact right there. And now I'm going to go ahead and give it a few turns. And now we have a couple of options. We can simply continue to run and let it come out of the ejection side, or we could put it in neutral, but I'll go ahead and use the jogging features. So let's jog up, which is just enough to allow me to get in there, and now I can take my measurement. So if your target goal, in this case my target goal was 1135, I'm measuring 1185. And so that tells me I need to move this micrometer down 50 thousandths. So let's go ahead and, so we're at 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so I'm going to end cycle. We're going to place it back underneath, and I'm going to go ahead and hit run. Now I'm going to allow it to come all the way out so I can remeasure. So we're within 1/1000th of where I need to be. That's an excellent start, and we'll make our final adjustments once we have a fully loaded shell plate. So that is the proper setting of this die. So on our last station is our crimp die. And so what we want to do is start off by backing the micrometer portion up, and we're going to place the die in the tool head. Now at this point we have a case that already has a seated bullet, so I'm going to put it back into my bullet seating station. I'm going to do a single cycle, which is going to move it over to my crimp station, and now I will do a move to bottom. What we want to do is, again, much like the seating die or any other dies, we want to ensure that the die body does not touch the shell plate, or in this case, is also not contacting the case retainer station. So a good visual while we're threading this down is important. So we come all the way down, and we can move the micrometer portion towards us as the operator. So here I've got clearance on the shell plate, and I will lock it in place. Now we'll perform the rest with the micrometer. And again, we're going to lower it until we feel resistance. Once we have that resistance, we've made contact. I'm going to go ahead and be able to turn another 10 thousandths right there, and 15, and 20, and 25. So I'm getting a pretty good resistance, but now it's all about checking our work. So we're going to end cycle. We're going to take that round, and there's a few things we can do to measure it. So right off the bat, does it fit the case gauge? Yes, it does. So now we know it case gauges. But we also want to verify that it's not over crimped. And so very important when you're dealing with a plated bullet or a soft coated lead bullets. We can verify in one fashion by measuring the outer diameter, which in most cases should be about 377. You can see this one's a little light. And so there's a couple things we look for. One would be for bullet setback, and then we remeasure our length. We can verify that. We can also pull the bullet. We can view exactly if we have too much indentation or imprint on this. And so you can see that this is a good light crimp with no setback, and so it tells us we have set it properly.